Algebra 1, Section 10.4, solving quadratic equations using factoring. We begin with something called the zero product property. If I had to choose one thing that I thought was the most important thing in Chapter 10, this is it right here. And that doesn't mean it's the only important thing. There are tons of important things in Chapter 10, but if I could pinpoint one, this would be it. And the zero product property says if AB equals 0, then A equals 0 or B equals 0. Now, before we go any further, I want you to think of two numbers, just any two numbers that will multiply to give you 0. I'm going to stop talking for a second so you can think of that. Two numbers that have a product of 0. Now, I don't know which two numbers you picked, but I can guarantee you that at least one of them was 0, right? There doesn't exist any pair of numbers that have a product of 0 where one of the numbers is 0 or the other. And that's what the zero product property is based off of. If you have two things multiplying to give you 0, one of the two things must be equal to 0, okay? Now, the way that actually works in a problem for chapter 10 and in this section 10.4 is if we have something that we can factor, more specifically, if we have a quadratic that's set equal to 0 that we can factor, as I've done here, we can then go further and solve the equation that way. Now, this little note that I have here in blue, factor the way you did in Chapter 9, is to say that if you decided in Chapter 9 that the way you factor is using the grouping method, factoring by grouping, I want you to continue to do that. And your homework is going to be a little bit longer than someone who does trial and error. But there are pluses and minuses. I think I said that in that video. There are pluses and minuses to both of those methods, and I wouldn't want you to go ahead and try to change now, right? That's when the lead coefficient is something other than 1. When it's 1, we'll see an example like that. I think you should use trial and error because it ends up being just exactly the same process anyway, okay? Now, if you're a trial and error person, I think you should do trial and error. And you do two sets of parentheses, and you put your 2x and your x, and maybe you'd try 2 and 3, and you'd find out that they don't work, and you'd have to go with 1 and 6, okay? In any case, whichever method you use, this is factored form of this. And what the zero product property is saying now is that one of these two things must be equal to 0, and we need to consider them both. So either 2x minus 1 equals 0, or x plus 6 equals 0. That's the only way that their product can be equal to 0, okay? And the reason we do that is because we now know how to solve this. This is just a two-step linear equation. You could add 1 to both sides and divide by 2. One of your solutions is x equals 1/2. Here you would just subtract 6. And your two solutions are 1/2 and -6. The word here is not important. You could just use a comma or the word and. I usually use or, but it's not important. Okay? But there are two solutions, 1/2 and -6. Let's practice that. Says, this is very similar to the one we just did. It's already in factored form, solve using the zero product property. So again, what you should do, actually I'll just roll to their answer. You should have 2x plus 3 equals 0, or x minus 4 equals 0, and then just solve those. That's exactly what they're going to have here. And they'll get -3/2 and +4. That's using the zero product property. Here's one that will factor. And like I said a minute ago, if the lead coefficient is 1, that's assumed to be a 1 right here. I think trial and error is the way to go. I think I demonstrated for you in Chapter 9 how using grouping here would still work fine. You'd go through some unnecessary steps because basically what you're doing is either method, you're trying to find a product of 42 that has a difference of 1, okay? So obviously x and x are going to go here. Those two numbers that have a product of 42 are going to be 6 and 7. And then you're going to want the bigger one to be positive, so that would be 7, and where the 6 is negative. Okay, that is factored form. Then you apply the zero product property. One major mistake that I do see students make is they don't make a distinction between the direction factor and the direction solve by factoring. Okay, if I just gave you a quadratic and I said factor, your answer is just factored form. This one here says solve by factoring, and notice that it's not just a quadratic, it's an equation. x squared plus x minus 42 equals 0. This is something that we can solve. And the way we solve this is using the zero product property. So this here, if you added 6 to both sides, that's one of your solutions, 6. Here you would subtract 7, x equals negative 7. These are your two solutions. Now I want to draw this to something else that you should be familiar with, and that is the graph. In the previous section, we were solving quadratics by graphing. You still could do that. That wasn't the direction here, but you understand you would still get the same two answers, positive 6 and negative 7. And what this would look like would be 1, 2, 3, 4, 5, 6. Here's negative 7. There's a point there. Positive 6 is right here. The parabola would open up because that number is a positive 1. I know that this parabola would open up. In fact, I do know also that the vertex would be halfway between these two. It would be at negative a half. So something that looks, I mean, it's a sketch, but something that looks just about like this would be what that parabola is. Crossing the x-axis at our two solutions that we found by factoring, positive 6 and negative 7. All right, let's try one a little bit more challenging. And again, if you're a trial and error factor, then go ahead and do that just to give equal time to both groups. I'm going to go ahead and do this one by grouping. First of all, you want to subtract 21 from both sides so that you have this set equal to 0. It must be set equal to 0 in order to use the zero product property, right? It wasn't called the 21 product property, where it's equal to 21. It's called the zero product property. So I subtracted 21 from both sides so that we have it set equal to 0. Now again, what I would do is for factoring by grouping, folks, AC is 63, 1 and 63, 3 and 21. Actually, it's going to be 7 and 9. 7 times 9 gives you 63, and those are different by 2. Review sections 9.8 and 9.6 for help on that if you didn't follow what I just said there. Different because of this sign by this number 2. So I can rewrite this as 3x squared would be minus 9x plus 7x minus 21 equals 0. Factoring by grouping, I can take out a 3x from the first two terms, leaving me with x minus 3. Taking 7 out of the second two terms would leave me with, again, x minus 3. So factored form would be 3x plus 7 times x minus 3 equals 0. Okay, so if you're factoring by grouping, that's how you would have done it. If you're factor by trial and error, then you would have your work would just be this right here, and you started with 3x and x, and maybe you did start with 7 and 3. That probably would be the most likely. That would be the way that I would have suggested you did it. So either way, we come up with this. And then we need to use the zero product property. 3x plus 7 equals 0, or x minus 3 equals 0. Subtract 7 from both sides here, and divide by 3. We can just leave that as a fraction, negative 7/3. My startboard's being a little goofy today. I don't usually write that like a 7-year-old, but. And here you'd add 3. Okay. And one more for application. The diagram shows a pattern for an open top box. The total area of the sheet of material used to make the box is 130 inches squared. The height of the box is 1 inch. That is to say that if you fold it on the dashed lines here, you'd have something coming up out of the screen, if you will, a three-dimensional figure that's 1 inch tall. And they want us to find the dimensions of the box. And they're calling the width x, and then the length is 3 more than x. There was a problem in the homework a section or two ago that was kind of similar to this. Do you realize that this being x plus 3, here's 1 more, and also here's 1 more, so this whole thing would be x plus 5. Common mistake would be to say x plus 4, but you got to add 1 to both sides, so it's x plus 5. This would be x plus 2. Okay, so x plus 2 times x plus 5 is an area that they told me is 130, right? Width times length, which I have expressions for both, they told me in the problem is 130. Now again, can we just go ahead and use the zero product property? We cannot, because this is not zero, it's 130. So we do need to go through the process of multiplying this out and then incorporating the 130 into it, and then we'll factor it again. Watch. X squared plus 5x plus 2x would be plus 7x plus 10 equals 130. Then if I subtracted 130 from both sides, you'd have what you see there, which is equal to 0. And then we can go ahead and factor that back out. X and X. It could be 15 and 8. Yeah. Your brain probably gets drawn to 12 and 10, but it's not that. We got to go further out. Yeah, it's going to be 15 and 8. I had to think about that one. 15 and 8 will multiply to give me 120. They're different by 7. We want that to be positive, so this will be plus 15. This will be minus 8. Okay? Now let's continue with the problem. Zero product property. Now I can use it. X minus 8 equals 0. X plus 15 equals 0. This would be x equals 8. This would be x equals negative 15. Okay? Now before we finish this up, just think about those two answers. Look at what x was. Look at your two answers. Are they both reasonable? You see the solutions to the equation that we started with are for sure 8 and negative 15. But only 8 makes sense for the problem, right? And I think that would be in inches. Negative 15 could not be this width. It could be not be this length. So could not be part of that length, that is. So x equals 8 would be the solution. They did say find the dimensions of the box, right? So to plug that back in, the box is going to be 8 by 11 by 1, right? 8 would be here. 11 would be 3 plus 8. And then we already knew the 1. So it's an 8 by 11 by 1 inch box. All right, now that was section 10.4. 10.4, over and out.